Hi folks, my name is Alek Sharma. I'm a developer advocate at CircleCI, and I am here today to talk to you about continuous integration, which is a software development practice where everyone on the engineering team is continuously integrating these small code changes back into the code base. After each change that they're making, there's a suite of tests that runs automatically that checks the code for any bugs or errors or anything like that. Cool, so what does that look like in practice? I've drawn this beautiful flow chart up here for you. Step one is you make a change, and this is something maybe on GitHub. You make a feature branch, you push it up, submit a pull request. That's the change that I'm talking about here, okay? Push that up, then you run your tests automatically, and that's pretty important. The tests need to be run in a consistent way so that everyone on your team has full confidence that they're running the tests in the same way. You don't really have a guarantee that your machine is the same as your neighbor's machine. That's really hard to lock down. So those tests are running automatically somewhere else. If they pass, right? If they pass, you're good to go and you can just keep making changes, right? You go right back around, submit another pull request, go wild. If the tests fail, you need to make sure it's your responsibility to fix the code. Okay, fix the code until your tests pass, and then you can continue developing. So it's this wonderful cycle. The idea being that you want to catch these bugs as soon as you can, right? So they're not lingering over a long period of time. So that's what continuous integration is, and next time we'll talk about why you would be doing this. So today I'm going to talk about why continuous integration is such a good thing for you. So you might have picked this up from last time, but it's just safer, right? The fact that you're running tests after each little bit of code means you're going to catch bugs before they even happen. It's kind of like Minority Report for software development. Think about it that way. That's a movie reference. So there's fewer bugs, okay? And then there's this wonderful byproduct of doing proper continuous integration. And the byproduct is that it's hard to continuously integrate large amounts of code, right? Because there's more of a chance that you'll get a merge conflict, right? The amount of code, if it's small, they will probably agree with each other and you can integrate them. But if it's big, then you're gonna have trouble actually doing that on a regular frequency, okay? So you're moving faster. You're making smaller changes, but you're doing them more often. And what that leads is to more features. You're actually able to make an impact faster. You don't have to wait weeks to actually see your work out in the real world, as long as you're doing continuous delivery, and we'll talk about that later. The second thing is that you're making better decisions, right? Because you get your stuff out into the world faster, it means that you'll be able to figure out whether or not your users even like what you built. So you might be able to test a theory more rapidly than you would if you were taking months, right, to build an entire release. And so that's kind of the whole idea, is that this iteration speed really increases the quality of your code. Not only is it safer, but also it better matches what people even want, because you have a better understanding of what people are actually using because of how quickly you're moving in these small increments. So cool. I think that about does it. From a high level, that's kind of why continuous integration is so exciting and nutritious to software developers. And look at this. I'm not even on the screen. I'm sharing my screen instead. So today I'm going to show you how to set up a project from GitHub on CircleCI. And we're going to break a test, we're going to see it pass, and we're going to move on with our lives. It's going to be great. So the first thing that you're going to need is a project of some kind on GitHub. I've chosen, because I'm a little bit biased, CircleCI docs. Super creative, I know. So I forked CircleCI docs, and we need to clone this down. So we'll head over here. Let's just see where we are. Good. Then we'll clone in here, enter your password, don't tell me what it is, and wait, depending on your internet speed, and I guess the project size as well. CircleCI Docs isn't a traditional web application, it's just a Jekyll blog, but we do have tests, and that's really kind of all we need to get this going. So the one thing I am going to show you before we head over to CircleCI is the config file. And this is where all the wonderful stuff is located. This is the single file where you will put the instructions to CircleCI on how to run your build. So you'll put in environment variables, you'd put in steps to actually check out the code, restore dependencies from cache if you have that. You can run very specific commands. And this is really almost infinitely customizable. And we're not actually going to focus on that today. We've got plenty of documentation on how to set up good configuration for your projects. And we've actually got some great boilerplates. And if you're on our previous version of CircleCI, you can actually, some of these configurations are actually inferred for you. But anyway, don't worry about that. All you need to know is that this is just kind of a list of instructions. And we're going to see the names of these steps play out on the actual build page when we run our tests. So let's add the project here. I'm in the CircleCI app here. I've already signed up since I work here, but you will have to do that, and you'll just have to authenticate with either your GitHub or your Bitbucket account. Most likely it's GitHub if you're following this video. So I'm going to add projects. And I want to build on Linux, so let's do that. And here are my repos on my account, but I want my fork of CircleCI docs, so let's hit Setup Project. I want to use the new platform, obviously, super shiny. I don't think you need to list the language, but let's just put other because it's mostly just a Jekyll thing, so let's not worry about that. So now it wants us to, it's telling us create a folder named .circleci and add a file config.yaml. Well, we already have that actually because I forked it and we've written that for CircleCI docs. That's already been done for us. So we don't need to do that. So let's just start building, right? Let's just go ahead and do that. And we'll save the hard work of building a configuration file for another video. I just want to show you what this actually feels like to use CircleCI. So here we have the build is running. We can see when it started, so we can see how long the build is actually taking to run. If you've purchased more containers, depending on your plan, you can run things in parallel. So that's kind of nice. And yeah, we have an estimation of the build time. This is really, it's really helpful stuff at the top there. So let's look at what's going on. This is all part of the test phase. We're spinning up the environment, we're checking out the code, we're storing the cache, and these should look familiar because these are the actual steps in the configuration file. So I didn't just lie to you when I said that we are consuming these steps and then just performing them. So this is going to take the longest, test with HTML proofer, and what this is doing, it's going through and making sure all the links actually work. Which is important for a doc site. You don't want to have broken links scattered throughout your documentation. So this is our testing phase here. And so now I'm going to just have to talk a little bit while we wait for the tests to finish. But what we should see is that the build passes. I don't expect any sort of tests to be failing. It actually says it's passing here, but I'm not sure whether that's inheriting the main CircleCI docs build, or if it's taking my fork. So we don't actually know. So it looks like all the tests did pass though. We moved past the HTML proofer phase, and now we're uploading artifacts. So great. And I think this is just a copy of the whole site. All right, cool. So great, we're done. You can probably hear my fan going off, and I think that's because I'm recording my screen. My Mac is angry. So this is fixed. It says fixed because I believe it thought it was broken up until now because it's inheriting all the demos I did before this. So we have a green build, and that's excellent. But let's break it and see how that works. So say you're going along, you're working on some code. In this case, it's just Markdown. But say you remove something and you make a typo. And what we've done here is we've broken this link. So this link will no longer work because it doesn't have the rest of the domain name included in this link. So this is an incomplete link. And hopefully our test will catch that. So we will add this change. Yep, that is what I want. We'll commit this, broke a link. Whoops, And then we'll push this. Now, I'm just pushing from master to master, and sometimes that can be dangerous in a production environment. But a key part of continuous integration is committing and pushing everything to a mainline branch. So we have to obey that the rules of the game. Okay, so we've just pushed this up. So now what we should see is, or wait, this is going to be anticlimactic. We don't want to see build 8. There should be a new build starting. Build number 9. Broke a link. Whoops. This is going to be really, really exciting, because we're going to see the tests fail. Okay, so let's just take this time while everything is building to talk about why this is so helpful. So someone just made a change, and they merged it in pretty quickly, right? That wasn't a ton of work that we just did, but within minutes, we're gonna find out that master is broken, and that's really important because other developers who are depending on master, they're relying on master to actually be correct. They won't be able to branch any new work off of a unstable mainline branch. So this is kind of the crux of why this is so helpful. Is you might have this tab open. Okay, see how we broke this link? So we failed the tests here, and that's going to land us with a failing build overall. So green are steps that have finished successfully. Red are steps that have failed. Cool, so it's failed. And now we need to do what anyone should do in this situation, which is fix the mistake, fix the red build. So let's actually just, luckily it's in my undo buffer, so I can cheat and do that. Cool, so let's bring the base URL back. Let's add this, fix the link, and then let's push this back up. So I know this maybe this seems kind of repetitive, but this is the workflow. And in the majority of cases, this is kind of the percentage of time you'll be spending with CircleCI. You can see what changes actually broke the mainline branch, and you can see what brought it back to normal. And this is really important. This is the core part of continuous integration and the core part of what CircleCI does. There's a very clear version history of when things went wrong and at what times and how long it took to build. So yeah, this is the takeaway. Within minutes, we knew that something was wrong, and we were able to respond to it. And that's kind of the nature of the development animal that we're wrangling here. Is that we want to catch these things before they become real problems. We want to catch these small errors before they turn into big production outages. And this is how we do it. We want to keep these times as low as possible. So there's all these other fancy ways you can increase the speed of your build. And I mentioned parallelism. There's caching. There's all sorts of little tricks that you can use to make sure that the builds don't take any longer than they need to. And in fact, we could probably be optimizing our own CircleCI docs. It's unclear whether we need to upload all these, right? Like this is kind of a costly step, right? It takes a big chunk of time. So that's another thing, is that you have clarity into which steps are taking longer than others, and that can help in optimizing your build time. So we're hoping, right, that this build passed, and it looks like it did. So we fixed it, we brought it back to normal, and we just connected a project from GitHub to CircleCI, and you should be very pleased. Except I don't know if you were following along, hopefully you were just forking CircleCI docs as well. If you had your own web application, then you probably got hung up on this part because you don't know what to put in here necessarily. But that's another video for another day, and I hope this gave you kind of a good impression of what it's like to actually be using CircleCI along with GitHub. They work very nicely together. And what you can actually do is get really cool buttons like this, cool integrations like this. I think if I were to make a pull request, you would also be able to see whether or not the build was passing, the associated build is passing. And that's a really great tool for feature branches and pull requests. We didn't do that in this video, but you can kind of see how that would become a big part of your development workflow. So the last thing we should talk about is the difference between the three types of continuous software development processes. We've spent a lot of time on continuous integration, but these are closely related. All of these are very closely related, and they're often confused with each other because they are so closely related. So just a quick recap of what continuous integration is. All that is a software development practice where you are continuously integrating your changes into a mainline branch. And the whole purpose of this is to avoid conflicts. It's to avoid surprises by reducing the size of work that you're working on and then constantly merging those in with each other. Continuous delivery, on the other hand, is making sure that your code, that mainline branch that everyone is merging to, is always in a deployable state. So when, if you remember that chart that we did at the beginning of this series, that was actually sort of a combination of continuous integration and continuous delivery. I lied to you. The delivery part, the continuous delivery part, is the testing part. So having that suite of tests running every single time you merge your code to that mainline branch ensures that the branch is ready to go at any point. And so that's really the only difference, is that you're making sure that your code is ready to deploy at any given point. And often that means actually deploying your code to a production-like environment. So you're not actually shipping it to real users, but you are mimicking the environment that will be working out in the real world. So what's the difference between continuous delivery and deployment then? Continuous deployment, the only difference here between continuous delivery and continuous deployment is instead of manually deciding what changes to send out into the real world, if your code passes the tests here, it automatically gets deployed to users. So this is a kind of a risky way of doing things, but if you get to this point, that means your org is truly embracing this DevOps culture, truly embracing this continuous, lifestyle. That's the best way to think of it. So all of this is done in an effort to reduce this feedback loop between, we want to get stuff out to users as quickly as possible so they can give us feedback on whether they like it, whether they don't, what's working, what isn't. And so these can kind of be viewed as different steps on the spectrum of how continuous you actually are developing. So I hope you've enjoyed this series and hope you've come out a little bit more enlightened about what being continuous really is. Thanks for watching.